Here in 2.4, we're going to be taking a look at writing linear equations. We have really 4 objectives. You can see 3 of them are very similar to each other. But what you'll take a look at here is objective number 1, graph equations using the slope-intercept form. So that'll be something, hopefully some review there for you. Second one is write linear equations given a point and a slope. Write linear equations given 2 points, and write linear equations given a point and some other equation. So you can see most of what we're going to be doing is going to be writing equations. That's the big part of this lesson. But first things first, let's go ahead and take a look at really the main part of writing a linear equation. There's 2 things you must have, and notice double stars here, so this is important. The 2 things that you must have to write a linear equation is a point and a slope. So in class, or if in just in discussion, if we're talking about, and I say, well, what 2 things do you need to write an equation? Point and a slope. Those are 2 things that you need. Sometimes they don't give you those 2 things. You may have to find them, but those are the 2 things that you need in order to write an equation, is a point and a slope. Now there's 3 forms to write linear equations in. The first one, standard form, which we've talked about before. I'll just slap it up here. AX plus BY equals C. That's the standard form. The new ones are going to be number 2 and number 3, and we're going to be taking a look at those in depth here in just a moment. But slope-intercept form and then point-slope form. You're probably very comfortable with number 2. Number 3 tends to not always is not always the one we remember the most of, but definitely is one that we're going to use a lot now. So hopefully you'll remember it after class. Okay. Now let's go ahead and take a look at slope-intercept form of a line. If the equation of a non-vertical line, because remember if it's vertical it doesn't have a slope, so how can it be in slope-intercept form? In x and y is solved for y. The result is an equation of the form y equals mx plus b. If you want to put an equation in slope-intercept form, the idea is to get the y by itself. So y equals mx plus b. Now, the m represents the slope. And the b represents your y-intercept. Now remember, the y-intercept is the point 0, comma, something. We plug in 0 for x to solve for y to find the y-intercept, and you can see that down here in the notes. But that's how you would find the y-intercept. So y equals mx plus b is what we're going to be utilizing when they are referring to slope-intercept form. Okay? Now the 2 things that slope-intercept form really helps you is it helps you find slope. Because if you have the equation y equals mx plus b, or if I can put it in that form, it's pretty easy to figure out what my slope is simply by looking at the coefficient in front of the x. Now, there's some things. Remember, y has to be by itself. There can only be a 1 in front of it, so if it's 2y, it's not in slope-intercept form yet. So once y is completely by itself, whatever the coefficient is in front of x, that represents our slope. Very easy. It also allows us to find the y-intercept, which is a point. It's the point 0, comma something, right? We just talked about that. And so it allows us to have a point and a slope, which is really nice because it helps us to graph it. Okay, so the 2 things that slope-intercept form helps us do is it helps us find slope and it helps us to graph. So if I knew a point and I knew the slope, 1, 2, 3, and then 1, 2, 3, then I can go ahead and I can draw my graph. And so that's the beauty of slope-intercept, is that it allows us, assists us in helping us to graph. Now, some of the problems that you'll have when it says something like, hey, I want you to graph or write an equation. So we're going to be doing both of these, but definitely the write an equation part. When we look at something like this, slope is 4 and the y-intercept is 3. Now first off, let's graph this thing. And so we'll put a graph right over here, and we will plot the point. Now the y-intercept being 3 means it's the point 0, 3. Okay, so 0, 1, 2, 3, we put it on. The slope is 4. Keep in mind 4 is 4 over 1, because you want to write it as a fraction to figure out the slope. So 4 over 1, you can either go up 4 and over 1 this way, or 1, 2, 3, 4, and come down this way, and then over 1. And so either way, what you're going to get is there's your line. So that helps us to graph very easily. So slope-intercept form, the 2 things that we need to know can help us graph. Now, how do we write the equation of that line then, if this is the only 2 things we have? Well, if you know the slope and you know the y-intercept, you can jump right into your slope-intercept form. That isn't always the case. But if you know the slope and you know the y-intercept, the x and y are the variables, so they stay x and y, then all you have to do is simply replace the slope and replace the y-intercept. It's a fairly easy problem. Y equals 4x plus 3. Now we want to be careful because students have a tendency to understand that, but as the problems get more complicated, where you can't immediately jump into that equation, that's where they struggle. So again, this is a very basic introduction to this, and so hopefully you can see that. Another form for the exact same time problem is this. They may say m is equal to -2. Remember, that is your slope. And then they say it passes through the point 0, 2. Now we may take for granted, think this is just some random point, but notice when the x is 0, that means the 2 has to be the y-intercept. How do we find the y-intercept? We plug in 0 for x. So 2 is the y-intercept. So they gave us the slope, they gave us the y-intercept just like they did up here, and so you get y equals negative 2x plus 2. The 2 goes there, and negative 2 goes there. Those would be the very easy ones. Again, you're not going to have a lot of these types. But when you do, it's nice to be able to recognize them because we can jump right into our slope-intercept form very quickly, which is always a good thing. Now, if we take a look here using the slope-intercept form to graph something, now notice it's not in slope-intercept form, it's actually in standard form. So we need to rearrange this, and what we need to do is get y by itself. So I'm going to put a box around the y, I want to get it by itself. So I want to move the constants, which is right here, to the other side. So I'm going to get negative 3y, I'm going to subtract 4x. I end up putting that in front of the 6, and at that point now I can go ahead and get y by itself by dividing by negative 3. Whatever I do to one side, I got to do the other side. So it looks something like this. Now we want to look at this one over here and talk just a minute about this. If you notice, we have a single term denominator. Okay, a single term denominator. Oops. Better spell that right here. There we go. So the single term denominator, if you take a look here, I'm going to abbreviate it STD. It's a good way for you guys to remember it. For whatever reason, you guys remember STD. But whenever we have an STD, we stack and simplify. So when you have an STD, you stack and simplify. So stack and simplify when you have an STD. So here we have negative 4 over negative 3x plus 6 over negative 3. Then you can go ahead and reduce, and what you get is 4/3 x minus 2, slope-intercept form. So now what we have is we have a y-intercept of negative 2, right there, and we have a slope of 4 over 3. So I'm going to go 1, 2, 3, 4, 1, 2, 3. So up 4 and over 3 is positive. Draw my line the best I can, and there we go. We got our graph for that linear equation there. Instead of using a t-chart, which you can check yourself doing, we put it in slope-intercept form in order to assist us. Okay? Now let's move on to the point slope. Now the point slope is really sort of like the alignment of the formulas of the two. Slope-intercept form gets a lot of credit, sort of like the quarterback, running back, wide receiver of equations here. The point slope does a lot of work for us. Doesn't get a lot of recognition, but does a lot of work. And we need to memorize this. And it's right here. It's a little bit tougher to memorize than the slope-intercept form, I admit. But we got to get it down. And where it comes from is actually the slope formula. And we won't spend time here in the video talking about that, but in class we may. And so what we have here is we have any time that you've been given a point and a slope. Henceforth the name point slope form. And I have a tendency to exaggerate that because I want to make sure you understand what are the two things you need to write an equation, a point and a slope. As long as you know a point and a slope, then you can write a linear equation using the point slope formula. So what we have is y is the variable, x is the variable. These are my two variables. They don't change. They stay x, they stay y. The ordered pair is the x sub 1, y sub 1. That's the point, okay, whatever the point is. And then my m is my slope. Okay, so it's y minus y sub 1 equals m times x minus x sub 1. And that is our point slope formula. Anytime you've been given a point or a slope, you can write a linear equation using that. And again, for non-vertical lines, because if it's a vertical line that doesn't have a slope, I can't use it. Vertical lines are x equals whatever the constant is. If you get a vertical line, x is by itself. Horizontal y would be by itself. Let's take a look at this formula sort of in action in the next slide. This slide right here is just re-emphasizing what the point slope helps you determine or helps you do, and it is to write equations, linear equations. So anytime it says find an equation, write an equation, then you need to go, what two things do I need to write an equation? Number one, a point, and number two, a slope. Why do I need a point and a slope? What formula would I use? Well, the point slope formula. Y minus y sub 1 equals m times x minus x sub 1. So you memorize that, and then it becomes plug and chug. So here we go. Okay. Now, we got to be able to convert the point slope into slope-intercept form once we get it. So first off, let's look at our point slope here and make sure we see. We have y minus y sub 1, 3. Slope is 2. X minus x sub 1. Well, notice I didn't have x minus something. It's x plus something. Well, keep in mind x minus a negative 1 is actually x plus 1. So even though it says x plus 1, my x of 1 is actually going to be negative 1. So I want to point that out to you, that even though it's not x minus 1, it is x minus a negative 1. But how do we convert from this to slope-intercept form? Because you're going to have to do that quite a bit. And how to do that is simply through this idea of distributing and moving your constant. So we distribute, move your constant. It's the same every time. Distribute, move your constant. Distribute, move your constant. So we distribute the 2, the slope, throughout that bubble. And then we simply add the constant to the other constant. And what you'll notice is that isolates my y, so it's in slope-intercept form. So to go from point slope to slope-intercept, you really want to get down this idea of distribute, move your constant. Okay? Let's look at a problem. Okay? Find the equation. Ooh, find the equation. What two things do you need to write an equation? A point and a slope. Let's see if we know either thing. And they say put it in slope-intercept form. So our ultimate goal is to put it in y equals mx plus b form. But we may not get to start there. Okay? Let's see what happens. Of the line that passes through the point 4, negative 1. Now notice that point is just some random point. It is not the y-intercept, so I can't just plug it in here. We're not going to go to the pre-algebra style of plugging in the 4 for x and the negative 1 for y and plugging in our slope and finding our b. No, we're going to use the point slope formula. Y minus y sub 1 equals m times x minus x sub 1. Our slope is 2. They gave us that. So we know a point, we know a slope. Now it just comes plugging it in. Y minus, and label these, x sub 1, y sub 1. X minus x, or y, excuse me, y minus y sub 1 equals my slope times x minus x sub 1. So here I have y minus a negative, so that's actually y plus 1. And then as you can see here, if we need to put it in point slope, or go from point slope to slope intercept, then what we need to do is distribute, move your constant. It's the same every time. So we're going to distribute y plus 1 equals 2x minus 8. And then move your constant. Subtract that 1, and you're in great shape at this point. Boom, there you go. There's your slope-intercept form for that problem. Taking a look at the next two problems, notice this one, what we have is we have a problem where they give us 2 points rather than a point and a slope. So, okay, well, what two things do I need to write an equation? Well, I need a point, and I need a slope. Well, they gave me 2 points, so it doesn't matter which one you choose. You can choose either one, and it'll get you the right answer. But we do not know slope yet. So we go back to what we did back in 2-3 and say, well, how do I find slope given 2 points? Wait a minute, isn't that y sub 2 minus y sub 1 over x sub 2 minus x sub 1? So if I go ahead and label these, what I get is a negative 4 over 5. There's my slope. So now I have a point and a slope. So if they give you 2 points, you got to use the slope formula to find the slope first. And then you got a point and you got a slope. At that point, we can go ahead and do our point slope formula. So y minus y sub 1, there's our y sub 1, equals our slope, negative 4/5, times x minus x sub 1, which is 3 in this case. How do I go from here to point slope? Well, I distribute, and then I move my constant. I distribute, it's fractions, whoop-de-doo, we'll be all right. 4 times 3 is 12. Negative times negative is positive. That's how I got that. Then I go ahead and add 1. Well, anytime you add fractions, don't you have to have common denominator? So instead of 1, I'm going to write this as 5 over 5 so I can add those two. That's gone. Y equals negative 4/5 x. And then 12 plus 5 is 17 over 5. So even a complicated one like that is manageable. It's the same process sort of over and over. The last one we're going to take a look at here is a point and an equation. Okay, and when we're talking about a point in the equation, what we have here is we're saying that, look, I want to write an equation of something that goes through the point 4, 6. So anytime you want to write an equation, you got to know a point and you got to know a slope. And they gave us a point. We don't know the slope. However, it says that it's perpendicular to this equation. So if there's a way that I can find the slope of this equation, and I know that perpendicular slopes are negative reciprocals, flip it, change the sign, then I would know the slope of my line. So I look over here, notice this is in y equals mx plus b form. Ooh, that helps. So the slope of this line is simply 1/2. Great. So the slope of that line's 1/2. If it was parallel, our slope would be 1/2, but being that's perpendicular, I flip 1/2, so 2, and change the sign, so it's negative. Now I'm ready to put in point slope. Now we're just a machine at this point. And how do I go from point slope to slope intercept? Distribute, move my constant. Distribute, and then add 6, and there you go. You're at your solution. There's the equation of the line we're talking about. Okay? Get that process down, get that routine down. Last two we'll take a look at here. We have two ordered pairs. They want us to write an equation given two ordered pairs. So we go, well, what do I need? I need to know a point. Let's use 2, 3. And I need to know a slope. Okay, slope I don't know. They didn't tell me slope, but I do know 2 points. How do I find the slope given 2 points? Change in y's over the change in x's. Oh, look at that. 0 over 3 is 0. Slope is 0. Now, what kind of line has a slope of 0? That's right, a horizontal line. So if I wanted to write the equation of a horizontal line, isn't it simply y equals a constant? So in this case, what is y? 3. So I know my answer is going to be y equals 3. Now let me show you how you do this, even if you didn't recognize that. Y minus 3 is do the point slope. You got the slope. Here's your points. 0 times anything is 0, isn't it? Then add the 3, and there you go. If you look at the bottom one here, this is one where, again, we pick a point. We got, let's just pick 7, 1. And we need to find the slope. So it's the change in y's over the change in x's. Uh-oh. Uh-oh. Worlds are colliding. Okay? Boom. Explosions. Bad things are happening right here. That is a no slope. We're in big trouble. I cannot use the point slope formula if there's no slope. What kind of line does not have a slope? What kind of line is an undefined slope? Well, it's a vertical line. So we say have a vertical line. Well, isn't vertical lines x equals a constant? When x is by itself, that's a vertical line. Think of x-rays, your vertebrae. You get x-rays of your vertebrae. So vertical, that goes with x. Horizontal, horizon, horizon. I've had students say that before. Y is going to be horizontal. So in this case, what's our x value? Well, notice the x doesn't change. It's always 7. So x is 7. That will be our equation for a vertical line. So a couple of odd ones right here. Definitely the one that's vertical gives us some trouble. So make sure that you spend some time looking over that. Point slope. Here's the big thing. Anytime you're asked to write an equation, you must find a point and a slope to use the point slope formula. Y minus y sub 1 equals m times x minus x sub 1. Sometimes they give you the information. Sometimes, just like these two, you have to find what you're missing. And you want to use those resources appropriately. Okay? That was section 2.4, writing linear equations. Thank you.